Hello everyone, welcome to this video. In this video, we will be discussing about Azure AI Agent Framework workflows. So far, we have discussed a lot about how do we build chart-based applications using this particular framework. However, you can also very well build the agentic workflows using the same framework. Unlike the traditional tools that we use to build the workflows such as SharePoint, using the Azure AI Agent Framework, we can build the intelligent workflows. For instance, let's say you are part of a customer support and based on the customer request, you want to send the request to the retention agent or to a documentation specialist. So you will first understand what exactly the user is asking for or looking for, and based on which you will route the request to the corresponding team. So this workflow can be automated using this framework so that we can minimize the human workload. Another example would be, let's assume that you wanted to automate the data pipeline, wherein first of all, you need to read the news and summarize and translate that news to a different languages. So this can also be done with this workflow. The another sample, let's assume that we wanted to support the software development lifecycle. So we will have an architect who will go through the specifications, and we will have a developer who will implement that, and we will have a security agent, performance agent, or whoever is that. They will analyze the code and provide the feedback to the developer, and developer will rectify all these feedback. That's how we can completely automate the software development lifecycle. It uses the model called a direct graph. So direct graph, it's nothing but a mathematical structure wherein you will have a nodes are connected by the edge. So if you see here in this linear flow, you will have an input connected to the process that connects to the output node. And you can also have a non-linear flow wherein the developer node will be writing some code and submit to the reviewer. If a reviewer passes any feedback, the developer needs to fix it before the whole execution completes. So using this direct graph model, you can build both the linear and non-linear flows. We know that Azure AI Agent Framework, it's enterprise grade implementation. It does provide a lot of enterprise grade benefits. So to begin with, the observability, using which you should be able to understand every single step during the execution. Reliability, let's assume that if during the execution one node fails, then you should be able to catch that failure and rerun that flow without impacting the overall system. And multi-agent collaboration system, as we discussed here, there will be a number of nodes, so you can always have multiple agents representing each node, right? So that in that sense, you in this workflow you will have a multi-agent. And persistent, let's assume that if you're running a long running workflows, for instance, user is submitting for a refund request and that needs to be reviewed, approved, or whatever is that. If you have that kind of a long running workflows, you can very well pause and resume the workflow. Let's try to understand the overall hierarchy here. We will use the workflow builder to build the workflow. Within the workflow, we will have a number of nodes. Each node will be represented using the executor. Executor will be having a number of handlers. So think of this way, executor, it's a class. For instance, this is a customer support. The customer support will have a number of tools. So the handlers is nothing but a tool that the customer support will have it. Right, so likewise, this is going to be another node, say a summarizer. So summarizer will have its own tool, and this entire workflow will be running within that workflow runtime. Now let's see how do we build a simple workflow here. So if you see here, first we are initiating the builder as usual. If you see this particular diagram, we will have a workflow builder. So we create an instance of this particular builder. Then we need an executor, because if for a workflow we need an executor. So we create an executor and we define the executor something this sort. So the executor name, it's a greeting executor extended from the default executor class, and it has two different handlers. If you see here, executor will have a handler. So I have two handlers here. So now we have a builder, we have an executor. Now we are saying that, hey builder, set the start executor as this particular executor. So because say you have a number of executor, you need to tell the builder which is the start executor, and the, like from there, like we will be keep on adding the edges to connect other executors. In this workflow we will be having only one node, so we just say just the start executor, and we call builder.build, so that is going to give us the workflow, and we can run the workflow. As simple as that, right? So now let's see the detailed definition of each element. At first we have executor. Executors are nothing but a worker. Consider this as a kind of a support engineer, or a client processing engineer. So he is the person actually can do a bit of a work for us, right? So that is what the executor. And the like a handler, the engineer will use the tools to perform action. So this handler, it's nothing but a tool that the executor can use it. And typed message, so this tool need to have some information, right? So the typed message will pass that information or provide that information to the tool or a handler. Then we have node. So when you have a worker or a executor, you wanted to keep them into the workflow. In order to do so, you have to create a node. So node is nothing but a representation of a executor in the workflow. And edge, it's what connects multiple nodes together. And workflow builder, it's what we use to build the workflow. And context, like when we go from one node to another node, the context, it's what passed between these nodes. Say like you have a node A and node B. From node A you wanted to pass some information to node B, you can use this workflow context. So the workflow context, it's shared across all the nodes, so everybody will know the workflow context. And state and checkpoint, and let's say like you are running a long running workflow. In that sense, like a checkpoint will save the state of that particular workflow. Later when you want to resume that, like where you left that workflow, from that point you can resume that workflow. If you understand all of these, then building a workflow will be very simple. Now let's talk about some of the core methods here. First we talk about the yield output. So as mentioned here, this is the final result from the workflow. Whenever you wanted to pass the final output from the workflow, you will be using the yield output. At the same time, like whenever you want to send the message between the nodes, you will be using send message. And start executor, it's like when you build the workflow, you have to set what is your start executor, from which point it needs to workflow needs to start. And the add edges, like when you have the initial node, from that point you can say to, hey, like from this particular node you pass it to the next node. So likewise, like you can add multiple nodes, like connect multiple nodes together. Now let's see like the type of orchestrations. So first of all, why do we need a multi-agent orchestration? So think of this way, like instead of building one big monolithic agent, everybody will prefer the individual or independent specialized workers, and that's how the enterprise operates, right? And that's why like we need a multi-agent orchestration. And within the multi-agent orchestration, we do have multiple patterns. First, we have a sequential orchestration. So it name suggests from one node to another node to another node. The flow, it's very sequential. For instance, like let's say like the writer agent creates the draft, and SEO agent optimize that. Then finally it is reviewed by the editor. Or like the data entry agent provides the information, and that is reviewed by the risk management, risk and compliance, right? So that's how it works. It's so basically like sequential flow, right? Then we have a concurrent orchestration. Concurrent orchestration, like the task will be given to the multiple teams at the very same time, and we will be doing a aggregation. So for instance, like the market analysis, the sentiment agent, the pricing agent, and the competitor agent will analyze, provide that information to the product team to come up with a final report or code review. When you raise a PR, the security agent and the like performance agent, the stale agent, all will review your PR and provide the information, right? So that's what we do with concurrent orchestration. Group chart, it's like the manager will receive the information, and the like he will be collaborating with the various teams. He is the one who does the orchestration for us. And the like a hand up, it's like let's say like you are working as a support engineer in a support team. The lead engineer will get to know your incoming request, and he will see like what is that issue it's all about, and based on the type, he will assign the request to the support or a take or a retain or whoever is that, right? It's kind of a you will have a leader who will hand off the request to the specialized team member. Then we have a magnetic orchestration. So basically it's pretty similar to the group, but then here the manager will make a back and forth call between the agents, right? So the difference between the group chart and the magnetic orchestration, group chart, the conversation it's shared with everybody, and everybody will respond back to the manager at the same time. In magnetic orchestration, the manager will decide to whom to interact with, right? So that is the only difference between group chart and magnetic. So basically like these are all the patterns that we have, but it doesn't mean that these are all the only patterns. It has the ability for us to make or build our own pattern. Now with that understanding, let's go to the Visual Studio Code and try to execute the workflows. I will try to cover all the samples in 2 or 3 different videos. We won't be able to cover everything in this video. So before we try to understand the code, we need to understand the foundation here. I just go back here one more time. So if you see here, so this is how we build a workflow, right? So if you see here, like we have a node executor will have a handler. So now let's go back here. So there are 2 ways to define the executor. You can use the decorator based or a class based. We will look into the next sample, but now let's focus on the decorator one. So basically like what you need to do is that you need to use the decorator executor and provide ID, and like you will be defining a function. So I will come back to the definition in a moment, but if you see here, I have 2 different executors, one to handle the string, one to handle the number. So as usual, like I try to build a workflow using the workflow builder, and the like this is my the initial executor. I created the greeting workflow. Now I try to run the workflow by passing the string value, get the output and print the output, right? So now if I just come back here, I just print some information here, just to showcase, hey, like the workflow works, right? But the like in a real world, you will be doing your own implementation here. So if you see here, we just print, handling it's inside, and like it just print a hello. It takes a name and prints a hello, and it sends the message. And now we are using the yield output because like there is no further node. This is the single node workflow. So directly we are sending the results back to the workflow, right? Now if you just see here at the bottom, we are again building one more number builder workflow, and this uses the handle number as the node here. So it is pretty similar to the greeting workflow. Instead it just handles the number, it takes the number, right? And it also returns the value. We print everything. Now if you see here, apart from the first parameter, we are also passing the workflow context. Now with that understanding, let's try to execute the workflow. It's a 27 AGF executor decorator based. So now if you see here, we started the workflow by providing the input as a Karthik that went inside the handler. We just printed this value here, exactly that matches, and it says that I'm going to send this value back to the workflow, and like in the output section we are printing that value. Now what has happened is that if you think of this way, like it's a very tiny workflow with one single node. It takes the input, runs and prints the value. That's it, right? You can also build the executor using the class. So if you see here in this program, we are using the class called greeting executor extended from the executor. it has two different handlers. Exactly the same handler handles handle greeting, handle number, similar to like what we had. If you see here we are using the executor decorator, but instead of that, this is part of a class called greeting executor. Then we will create a instance of that. Then we create a workflow using the builder, and we set that as the initial node. Then we build our workflow and we run it. So let's go ahead and run this program here. So the result is exactly the same. The only difference is that instead of using the decorator, executor decorator, here we are just using the class. So we need to understand like what is the difference between the executor and the class based implementation. So if you just come over here, like whenever you wanted to build a simple workflow or a kind of a prototype, you will go with the executor. But like when you want to build the enterprise grade workflows, that most likely will be using the class based. The reason is that the decorator based one, it's a stateless, wherein like the class based one can be stateful. You can bring the state, and it is much easy for the third party integration. Say like you have some external integration, so using the class you should be able to do the integration without much of effort. If you look into this program, this clearly demonstrate the capacity of the class based executors. So here like I'm trying to create a support agent who will handle the user message and the system error code. So when user says, hey, like something it's not working, something it's slow, the support agent should be able to handle. At the same time, it should also be able to handle system related codes. Say system throws out of memory or high CPU usage related codes, it should be able to handle that. So now let's see like how do we use it here, right? So now first we create an agent. Then we create a builder here and set that as a initial node here and build the workflow. In the first run, the user is saying, hey, I'm having trouble with the login, and like next the user says, hey, my dashboard is also not working. In the third run, like we are getting some system related code. So for these two, it should be able to call the handle user message and able to process that. And then like for the last one, for this one, because this is a numerical based one, it should be able to make a call to this particular handler here. And if you see here, this is where like we will be making the call to the database. For each user query, we are just storing that information and retrieving that information into the database. Here like I'm not really connecting with the database, but I'm just saying that this is how we do it, right? And this is how the class based executor supports the integration with the third party component. Call it as a database, call it as a REST API or anything, you can very well integrate using the executor. So now let's take a look into the private method. So you don't have to write everything into the handler. So what you can do is that you can segregate or modularize using the private methods. So that's what we do here, right? So if you see here, exactly the same code, but what I'm saying here is that instead of writing everything into the handler method, I'm creating some private methods so that I can move my business logic outside of the handler. So handler will receive the input and then like it will make use of the private method to execute the business logic, right? This will allow us to follow all the design principles that the enterprise enforces. So now with that, let's go ahead and run the program. Let me clear the terminal. Now if you see here, the result is exactly the same. So the only difference is that instead of writing everything into the handler, we just make use of the private method. So this is the beauty of using the class based executor. Now I hope you understand the difference between the decorator based implementation and a class based implementation. Again, just to reiterate, the decorator based, it's for a simple workflows, but like when you go with the enterprise grade workflows, you will end up with the class based executor. So that's all I have for in this video. So we will continue to discuss all other patterns in the following video.